Hello and welcome to the webinar introducing AWS OpsWorks for Windows Server. The webinar will last roughly 1 hour and I will mix in some demos to make the webinar more relevant to you. After an introduction to the service, I will show you core concepts, dive deeper into technical details and speak about use cases. In my last demo, I will show you how to use OpsWorks to deploy a Node.js application. At the end of the webinar, there will be time to answer your questions. Due to the amount of attendees today, I can't ensure every question will be answered. Today, my coworker Jens is in the chat and will try to help me answer as many questions as possible. So feel free to ask questions at any point in time. The webinar will be recorded and put online if you want to view it again or share it. OpsWorks allows you to model, control, and automate your infrastructure. It gives you operational tooling, for example, the ability to manage user access to all of your instances. OpsWorks is also an application management service that gives you the tooling to describe how your software artifacts are deployed and automates that process for you. The OpsWorks service is free to use, but you will be charged for the managed infrastructure like EC2 instances or elastic IPs. You can look at OpsWorks also differently. OpsWorks is a service that follows the idea that infrastructure can be described through code. Code is reusable and documented. Most code is under version control, and it can be tested. The processes you use to manage your application source code can also be applied to the code that describes your infrastructure. Especially if you run your infrastructure at scale or in a dynamic environment where instances can come and go at any time, it helps you to keep up with your business growth. The structured description of your infrastructure lets you keep it compliant, it reduces manual effort, repetitive work, and therefore reduces mistakes when setting up environments. But let me introduce myself before we continue. My name is Mark and I'm a software development manager for OpsWorks. I own the OpsWorks Windows integration and should be prepared for your questions. Before I jump into the details of OpsWorks, I want to help those of you who might have heard or even used other services in AWS to understand how OpsWorks relates to them. OpsWorks is part of the deployment and management services, which focus on increasing your productivity when working with AWS. AWS offers 6 services in the deployment and management section. The recently started services Code Deploy, Code Pipeline, and Code Commit focusing on the development lifecycle, while Elastic Beanstalk, OpsWorks, and CloudFormation having a stronger focus on the infrastructure part. So let's see how OpsWorks relates to the services that are more infrastructure focused. Elastic Beanstalk is our platform as a service container. All you have to do is to bring a code artifact, and Elastic Beanstalk lets it run for you. To offer such a simplicity, Beanstalk is opinionated about how a specific application type is managed. On the other extreme, we have CloudFormation that gives you in-depth control of your AWS environment, so it focuses holistically on your infrastructure. The service helps you to set up all AWS services you want to use in conjunction. CloudFormation uses a JSON-based description of your infrastructure and services and creates or updates the whole setup for you. OpsWorks is in the middle of both and combines convenience and control. OpsWorks focuses on automation. It offers you full flexibility about how your infrastructure is set up, how your applications will be deployed, and it provides a complete lifecycle framework that you can use to react on any change of your infrastructure or application. OpsWorks manages the access on your instances for you and lets you run any kind of application at any scale. Because OpsWorks and Beanstalk are usual services of AWS, you can use CloudFormation to provision and configure OpsWorks and Beanstalk resources. So if you are familiar with CloudFormation, this lets you start quickly. Or you do something like this, which actually quite some of our customers do. You can use CloudFormation to create an OpsWorks stack together with all the AWS resources you need, and then use OpsWorks for your daily work. You should consider this scenario if you want to create and manage other AWS offerings in conjunction with OpsWorks. For example, you might want to create SQS queues, VPCs, and S3 buckets together with your installation or environment that you want to manage with OpsWorks. But this gets into very advanced use cases already. So let's step a little bit back and let me dive deeper into the OpsWorks core concepts. OpsWorks lets you organize your projects, stages, and environments in stacks. A stack might be your staging environment, your test fleet, your recently launched project, or a service that might be used internally or is customer-facing. A stack will group and organize all AWS resources and EC2 instances that belong together in some meaningful way. You might have a different stack for your development, staging, and production environment of your application. Another example would be a search cluster that is used by many different projects of your company, or a single sign-on service that is used for a range of applications for your customers. Another use case might be that you want to host a content management framework per user that you can scale and charge independently. Anything that belongs together in some meaningful way should be a stack. A stack contains layers, which represent the tiers of your architecture. A layer is a blueprint for a group of instances that have an identical configuration in common. So you would, for example, configure on an application server layer the details about your app servers framework and how to install it. You can configure the connection details for your third-party billing integration, or you want to describe how, or you have to describe how you want to deploy your application. And you want to configure your security groups and other network settings for all instances that belong to that one layer. After all your configuration is defined, you just have to drop in as many instances into a layer as you need. Because OpsWorks automates all the configuration for you, the instances can come and go based on your needs. And you can be sure that these instances are configured like any other in their layer. Let me show you how these concepts are represented in the OpsWorks web console. Everything I do in the web console is also accessible through our API and also in our SDKs, like the .NET one or other for different programming languages. With that integration, you have a good base for custom tooling around OpsWorks that fit your needs. Let me switch to the browser. This is a usual dashboard in OpsWorks when you have already some stacks set up. As you can see, I have 4 different stacks here, and I will add another one. If you want to add a stack, it should be with a meaningful name. So this one I will just call demo 1, because that's actually what it is. A stack belongs into a AWS region, so you can place it to a region that might be near to you, or you want to have a couple of stacks in different regions to be safe for any network outage. You also can configure VPCs and subnets so that you have different availability zones for your stack. For this webinar, we will choose not an Amazon Linux, but of course a Windows Server 2012. But you are also able to use your custom Windows AMI. That should be a Windows 2012 server, but can have additional software installed, licenses integrated, or whatever is needed for your company usage. The default root device type is EBS, and we will just stick with the IAM role that is auto-generated by OpsWorks. We don't have to take care of an SSH key because it's not very useful for Windows. And we will also stick with the default IAM instance profile, the EC2 role that we have. You can pick a hostname theme, and you can choose a color to easily identify it on the dashboard. So I pick orange and add the stack. Here we are in the stack dashboard. As you can see, I have different options where I can continue to set up my project. I have layers here, instances, applications, deployments, resources, and permissions. Let's add a layer. A layer is a very easy form. We just have a name, which might be application server, and a short name might be app. You can pick any security groups that you need, and you have predefined the OpsWorks custom server, default server, and RDP server role. The RDP server role has no permissions already defined. So if you want to connect to one of your instances via remote desktop, you have to open the port and specify the range of IP addresses that is able to connect to that server. But I will describe this a little bit later. Let's add the layer. And as you can see, there are many more options that you can pick from. We have recipes, networks, EBS, volume, security. But the most important one for me now is that I add an instance. The hostname is auto-generated from the short name of the layer and then suffixed with a number. I can choose the instance size, which is currently C3 large, but you can also pick an extra large one if you need it. And I place it in the availability zone US East 1A. Let's add that instance. And because I want to have failover, I put another one into a different availability zone. And then I will start both instances. And you can see instances were requested from EC2. And as soon as we have a public IP and a server available, they will go over into a pending mode, booting, all the setup will run. At the end, they will be online. But don't wait until a server is booted up and continue with our slides. OpsWorks also is deeply integrated with other AWS offerings. Like you might have recognized during the demo, that RDS can be added as a layer type. OpsWorks is also integrated with elastic load balancing, and you can put a load balancer in front of a layer so that all the traffic is equally distributed between all instances. OpsWorks also uses IAM instance profiles and users everywhere and maintains so a high security standard. In addition, you can always hook up OpsWorks to any other AWS offering by making use of IAM instance profiles, the API, and your own scripts that you utilize SDKs. Because OpsWorks offers application management, it defines apps as resources. An app can be the software that you want to run on your application server. You can specify the software artifact of your app. That can be a Git repository or an archive, like a zip file that you can put on S3. OpsWorks has an integrated deployment mechanism that you can trigger manually whenever you want to release a new app. This deployment can be executed either on your whole fleet or on subsets of it. Another important use case is that OpsWorks triggers a deployment on each new instance that is launching, so that each new instance will be deployed directly and behave like any others when it comes online. You can further customize your configuration or deployment with the ability to define environment variables that are then saved on your machine. For example, they can be used to configure API keys or other values for your application. This makes it easier to share application code between different stages like development and production, or customize apps per user if you reuse the application for different users. OpsWorks focus on your whole infrastructure from the very first streamlined provisioning until horizontal and vertical scaling for high load. It lets you initially provision and then continuously change your infrastructure. You can use OpsWorks to manage IAM users and their permissions for stacks and deployments, and grant access via RDP for a limited time. You can also adapt the size of your infrastructure based on usage patterns with time-based instances that start whenever you define it. And when an instance becomes unhealthy, OpsWorks can automatically replace it with its auto-healing feature. So let us get back to the browser and I show you how OpsWorks manages users and how you can use remote desktop. So as you can see, the instances are still booting, so it was pretty okay that we didn't wait for it. Let's switch the stack and I go to the RDP demo where I have an online instance already. As you can see here for the instance, there is an RDP link that I can click and I can ask for a session that lasts for a couple of hours. So for me, 2 hours is totally fine. And I can be sure that the access to that instance is removed from OpsWorks after these 2 hours. So I'm requesting a password, which is a one-time password only for that session. And when I get this password back, I also get the connection details for that instance. So the user mark is created on that box. I have a password here that I want to copy now, and I can download an RDP file. While creating the RDP session on the instance, I will show you how permissions and users are managed in OpsWorks. I click on permissions for that stack, open another tab. So, and you can see I have Jens, a local dev user, and myself on that stack with permissions. You can also see that the permission level is different. So Jens has only inherited IAM policy permissions. The same is true for my local dev user, and myself have managed rights, SSH and RDP access, and is administrator for that instances. Let's change that. So because Jens should be able to do also some work on my stack, I can decide if I want to not let him do anything on my stack, give him show access so that he can revise and see all the stack and layer settings. He might be able to deploy an application if I want to, or I give him also manage permissions. If you can see, all these permission levels that I can choose here with the radio buttons are all made for the OpsWorks settings in the console or over the API. So I can control what exactly Jens can do with OpsWorks itself. On the other side, this is meaningful for the instance access. So if I want that Jens is able to log into that instance via RDP in case of Windows, and he might be also an administrator, I can give him these permissions as well. Let's save. So now you can see I granted manage permissions for Jens and also RDP, right? So he can log in. If I go to the users settings here, I'm able to import all other IAM users that are known to my account. If I click here, I can import the admin user and import him to OpsWorks, and he will be also created then on all the instances with the appropriate permissions that I set on the stack level. But let's go back and see if the session is created. So we still have to wait a couple of seconds. Oh, there it is. So the session is created, which means I have the user set up on the instance, and that password is used to, or it's set for that user. So let me log in. I just paste in the password and continue with the self-signed certificate because I don't care right now for the demo. And you can see I'm logged into a Windows Server 2012. And I want to show you in the computer management section the local users that are set up. As you can see, Jens and myself are both on that instance, and we are a member of different groups. So because I just switched Jens to be an admin, he is not yet. So he has remote desktop access and he is part of users, while myself is also part of administrators. Okay, I can close that here and let's go back to our slides. You might ask how OpsWorks builds up these capabilities. Let's have a look behind the curtain. Because OpsWorks helps you with your daily operations, we need a software that runs on every OpsWorks managed instance. This is the OpsWorks agent. The agent is what makes OpsWorks so special and powerful. It's a software that runs on all your instances and is able to change every single bit on the instance. It is responsible for installing software and configuring your environment. This agent retrieves commands and configuration data from the OpsWorks backend and continuously executes commands and changes the configuration of your instances exactly how you specified it. The agent reports the command status back to the OpsWorks backend and continuously sends keep alive data that is used to represent the health of your stack. And OpsWorks uses it to auto-heal instances of which no keep alive data is received. The commands the agent reacts on describe important events in an instance life. For each of the events, you can attach a script that is called recipe, and it's executed and has up-to-date information about the state of your stack. Let's go over each of the events and see what you can use them for. The setup event is triggered always when an instance boots. It lets you define which software is actually installed on your instance, and in case you have defined an application for that layer, it will also trigger a deploy event. The configure event is one of the most important events. It is always triggered when the state of a stack changes. For example, you add an instance or one of your servers becomes unhealthy and is replaced by OpsWorks. Every instance of your stack will then receive the configure event and can react on the change. You might want to reconfigure your database to let the new server access it, or you want to tell your load balancer that workload can now be pushed to that new instance. The deploy event is triggered whenever you want to deploy an application and is also triggered from the setup event so that your instance is launched with the application already deployed to it. The undeploy event is useful if you want to remove an application. When your app is deleted, the undeploy event is automatically triggered on all instances. You can attach a script that then shuts down the app and removes it from the instance. The shutdown event is always triggered when an instance is shut down. You might want to execute a script that stops services like your database service, ships the last logs of that instance, or triggers an EBS snapshot to be able to restore the current state of the instance. In the end, the scenario might look like this for the lifetime of different instances in your stack and for different layers. So I will show you now 3 different layers and how the events will be consumed. In the lifecycle of the reverse proxy, it will receive first a setup event that installs and configures IIS to be a reverse proxy. Whenever a configure event appears, all instances will sync the app server IPs. Deploy and undeploy aren't used on that layer because there is no app running. On shutdown, you want to drain the current connections before the instance becomes unavailable so that no errors are surfaced to the user. The .NET App Server will install on setup the IIS. On configure, maybe because a new database slave arrived, it updates the database IP address and your app can connect to it. Deploy updates the application source code and maybe has to restart IIS. Undeploy removes the code and might shut down IIS if you like it that way. On shutdown, your last logs will be shipped. The database is installed on setup. On configure, it synchronizes the database access control list and it's not reacting on deploy or undeploy. When it receives a shutdown event, it maybe should do a backup before it dies. Let's come to the third demo. I said that you can configure scripts per event on each layer. I switched the stack to use the Windows Node.js demo stack where I can show it a little bit more in depth. Let's go to that one layer and I click on recipes, and as you can see here, I have a repository URL and I have my lifecycle events: setup, configure, deploy, undeploy, and shutdown. And for each of these events, I can specify a list of recipes, the scripts that are running on these events. As you can see here, I have a web server Node.js setup recipe and I have a web server Node.js deploy. It's a common practice to name the recipes accordingly to the event they should be triggered on. Let's go back to the slides. Okay, that sounds awesome, right? But how do we configure your instances, deploy apps, and what are those scripts? The scripts I talked about that you can attach to each lifecycle event are called recipes. OpsWorks did not reinvent the wheel, but is using Chef on the instances for configuration management. Chef is an open source configuration management framework. The code is organized in something that is called a cookbook, and each cookbook includes a selection of recipes. You might think of an IAS with different recipes, one for setting it up, one for managing all IAS features, and one for the site configuration, and so on. Chef is using a domain-specific language for describing configurations based on the Ruby programming language. You can find a lot of resources on how to use it on the web. I will now show you that Chef focuses on a very easy to learn DSL, and you are able to write your own recipes right away. These are two very basic examples how to install software. Windows features are built-in software that just needs to be enabled. Other software is delivered as a package with a source that it can be downloaded from and installed, like the 7-zip in our example here. As you can see, here is the URL where 7-zip is downloaded, a checksum to verify that you actually downloaded the right package, and an action that installs it. Chef is smart in that case. Even if you run those recipes over and over again, Chef will only install the package when it's not yet there. An installation is idempotent. Both recipes here make use of Chef resources. Windows feature and Windows package are those resources, and they give you a lot of convenience for further recipes. Resources describe a desired state. They have attributes and actions. Here's a slightly bigger example. It ensures that we have a registry key set. For simplicity, I choose the background color. As you can see here, the resource in this case is the registry key. We have the attributes key and values. The key is obviously the registry key, and the values are the background color that I want to set. And we have an action that is create, but it could be also something like create if not exists, and others. But there are many more resources that Chef provides you. Besides the registry key resource, you can also use a couple of others to have full control over the configuration on your instance. To highlight some that are more relevant for Windows users, Windows Service lets you activate, start and stop Windows services, or Remote File to let you access files from a network path. Very powerful is the PowerShell script that lets you run any PowerShell script that you probably have anyway, so that you can start with your existing configuration scripts and extend it with all the automation Chef and OpsWorks offers you. So if your deployment is scripted with PowerShell, you can use that and bind it to the deploy event, and you are done. So let's talk a little bit about OpsWorks and its Chef integration. OpsWorks provisions your instance and installs the agent for you and enables the features we just spoke about. After that preparation phase, the instance can be configured and used how you envision it. OpsWorks triggers Chef runs on demand with the cookbooks you specified per lifecycle event and whenever they are received. You can of course trigger all these events manually, for example when you want to deploy an application. Within your recipes, you want to use information of your stack state and execute or adapt your configuration accordingly. OpsWorks synchronizes the state with all instances so that you have that information available when you run your recipes. For example, you want to change your database config to use the new slave database of your stack. Let's have a look at this code snippet. To find the information you need, you can use chef search. It lets you find the instance of a certain role, in this case, the DB slave. You can see here this little star at the end, because you might have different database slaves and they are numbered. In that little block afterwards, you have all the database slave nodes and you can iterate over them. And you can use then the private DNS attribute of your database slave for further configuration of your instances. Let's put all the puzzle pieces together. I will show you a complete OpsWorks setup with Node.js application on Windows Server, and we will also run a deployment. Because it would take a while to set up everything, I will just use that already prepared stack and guide you through all the configurations that I did here. As you can see, the stack already has something set up. I have 4 online instances, I have 1 layer here, I have an application, and I already did a couple of deployments, as you can see. Let's have a look in the stack settings. So everything I set up here is like we had it in the first demo. But in the configuration management section, I want to show you this. Because we need to know where your chef cookbooks and recipes are, you can specify custom chef cookbooks. And then you give us either a Git repository or an S3 link with an archive to your chef cookbooks and recipes. You can use the Git repository here, use an SSH key that you need to download the code from Git, and OpsWorks makes sure that we download the cookbooks for you on all instances. Let's have a look on the instances. As you can see, I have defined 7 instances for my web server Node.js layer. 4 of them are already online, and I have a couple of stopped ones. Because we are already in the evening in Germany, I start a couple more servers because I expect high traffic for my super cool site now. And as you can see, I have different sizes. So I might want to have an X large instance running 24/7. I have a smaller one that is time-based, and I have a couple of different ones that I use later. I also pick different availability zones so that I have a failover if one availability zone is not reachable by network anymore. So all these instances I just started are going through the cycle of pending, booting, and will become online hopefully before we end the demo. Let's have a look at the time-based configuration. So why do you want to have time-based instances? If you think about an application or a project that has a very standard usage pattern, like you have a business application that is used in your company during normal office hours, or you have maybe a shopping site that has high traffic over the evening, you want to make sure that you have extra power when you need it. And because you can predict when you need your extra instances, you can configure it here. So let's say this web server node 2 should run a little bit earlier because people start earlier in my office, and I do that every day. You can see the box is in a darker green, the other ones are in a lighter green. So this means every day my instances run from 6 until 12 and from the afternoon until the early evening. But I can also customize that for every single day, and maybe on Saturday and Sunday I don't have any traffic at all, so I don't need extra instances and just run with the normal 24-hour service that I have. So this is a very usual use case, and you might like that a lot if you have predictable patterns. As you can see, the servers that I just started are running the setup so that they are configured and have the app deployed as every other one. You might have noticed already that here I have using ELB, the Node.js load balancer. Let's have a look at the layer setup. As you can see, an elastic load balancer can be attached to a stack. It also tracks how many instances are currently available for that load balancer and which are not attached yet because they are still booting. This updates every couple of seconds so that you can see if maybe some instances are not healthy anymore, and the load balancer will make sure that you can go through all of them. If I just click on one of my instances, I can show you the application. So this is it. Sorry. It shows you which browser I use, and it also tells you that I'm using Node.js version 0.12.6 to render that page. And I can leave a comment here. And we'll save it on that instance. Because I haven't set up any database, so that's single instance storage only. But if I go to the Node.js load balancer, I can see I just hit one box that has no comment at all. And I can try to find the ones that I just showed you. Oh, and here you can see there are some more comments. So this is what the load balancer does. It just evenly distributes through all the online instances traffic so that you get one whenever needed. But this is still a very basic setup, and not all of our customers have such a simple application environment. So let's go to the more advanced stack here. So this one has more layers. It has a couple of instances and also has an application. Let's have a look at the layers. You can see I have attached a load balancer to a reverse proxy cache layer. So that reverse proxy has as a backend the web server Node.js layer, and you can see here the RDS integration. So there's one RDS instance that can be used from this Node.js server. I didn't set it all up because that was too much work right now, but this would be a usual setup. So you might want to have a load balancer, some app servers, and a database that covers all of that. What I haven't shown you yet is the application section. So I said that OpsWorks defines an application. If I go to that one, it's called Hello App. What can I configure here? So I have a name for it. I can say that I want to use RDS or no database. I also have a repository that has my OpsWorks Windows Node.js example code, so it's the application code. It uses an SSH key to check out from Git, but I can also use a zip file. And here are my environment variables. So I have an app admin email that is admin.mycompany.com, and I could change that to your company. And maybe you want to have a license key in here. Therefore, I would use a protected value. A protected value means that this value is not surfaced in any API call or in the UI anymore. So it will be transferred to the instances, but you will not accidentally have it on your screen. So let's save that. And you want to deploy it again. So you can have a message here like live deployment. And then you can choose on which instances you want to deploy. Let's say I just want to update this one instance. I click on deploy, And I will have basically one Lightning instance that has that application deployed. If I go to the deployment section, I can see, okay, there were a couple of deployments, and if I look into one a little bit more, I can see that the usual duration is 3.5 minutes for one deployment of that app. This depends a little bit on what you do with your deployments, and I guess we don't have to wait for it. Instead, we can go back to our slides and I give you a conclusion. So let's wrap it up. OpsWorks gives you a concept of logical grouping that helps you to deal with your infrastructure. OpsWorks helps you to automate the provisioning and ongoing configuration of your project. You can hook into every lifecycle event and execute chef recipes that let you react on a changing environment. And OpsWorks offers you tooling like auto-healing, user management, and integrates with other AWS offerings. If you want to keep in touch, we hope to create more webinars in the future, and we are on Twitter. If you have a blog with posts about we have a blog with posts about our application management services, and we will make sure that we have more blog posts about Windows in the future. And there's one last thing. So in every console we have a feedback button, so please use it. It will open a dialog, and you can share any thoughts with us, and be sure that I will read it if you click that button in the OpsWorks console. Every of your input is very valuable and will maybe influence our decisions how to proceed with our product. Thank you very much for joining the webinar today, and please give us feedback. You can find us on Twitter. AWS OpsWorks is our username, and I'm very pleased to have you all in the chat now and answer your questions. Thank you very much.
Hey everyone, thank you for taking the time to fill out the poll questions. Our speaker Mark is currently reviewing all the incoming Q&A questions and will address some of these questions in the next 20 minutes. So please, if you have any questions, submit them in the Q&A window and Mark will address some of them shortly. Thank you. Thank you.
Hi, so I have a question here that might be interesting for you guys as well. Is Chef the only way to script in OpsWorks? So, kind of yes and no. So, we will use Chef on the machine to execute scripts, but actually you can use any PowerShell script and execute it through OpsWorks. So you would have a very, very thin Chef wrapper, and as you can see, that is only 1 or 2 lines of Chef code around a PowerShell script that you can use as usual. And I have another one that I can also answer to everyone. So about time-based instances. Yes, time-based instances boot up and configure themselves, and they also shut down when the time is over. So they can come and go, and because they are automatically installed and configured, you can be sure that they always fit to the current configuration. So all the resources that So Scott asks if all the resources that are created by OpsWorks are still visible in the portal. I guess what he means is if there are normal instances in EC2 and so on. So everything that OpsWorks does is using API calls internally. And yes, if we create an instance in OpsWorks, it will be a normal EC2 instance. So if you go to EC2, you can see it there. I would recommend to not stop at the instance in EC2 because then OpsWorks might not see that. But actually, they're just normal instances like any other as well. Any reasons? So I have another question from Eric. Any reasons to use both Beanstalk and OpsWorks? So yes. So what Beanstalk offers you is a very, very simple and easy starting experience. So you can just bring in your source code and it runs. So if you have a very simple setup, maybe your company block that you don't have too much sophisticated things going on, just go to Beanstalk and it runs in a couple of minutes. What you would use OpsWorks for, as I said, you might want to have a single sign-on service or search cluster in OpsWorks setup that is a bit more sophisticated, that has way more logic how to deploy it and way more resources to be used. If you want to have something that is more customizable, Beanstalk is not the right tool, and OpsWorks helps you a lot there. And what you can do there is if your company blog post needs that search engine, it's very easy to just configure then an IP address in OpsWorks that can be surfaced to the Beanstalk application so that you can use in Beanstalk that very sophisticated application. I have a question about CloudFormation. So would you use CloudFormation for setting up VPC security groups and then use OpsWorks to manage individual EC2 instances? Actually, yes. So security groups you can configure pretty easy even in our UI in OpsWorks. But you might want to have a couple of more AWS services put together to be combined for your application. And what you then do is the individual instance setup can be done through OpsWorks, and I guess that helps a lot to get your whole application put together. I have a question about Chef. Is there a webinar for beginners on Chef scripts? So Chef is an open source tool that is very, very well documented. So you can find one-on-one sessions on the Chef website, and we also have in our documentations getting started guides for Chef script. So I guess that you will not run out of resources if you just type in Chef recipes OpsWorks. You will get a clue about how to do that, and the standard documentation of Chef applies to OpsWorks as well. I have a question here about already live instances. Currently, you can use existing instances only together with Linux and not with our Windows offering. But we are working on having the same abilities in OpsWorks Windows and OpsWorks Linux, so that we close the gap in the future. So currently, that's only possible with Linux. William asks if you can get a copy of the presentation slides and recording URL. I'm pretty sure that this will be available to you soon. So as soon as the presentation is recorded and mastered, it will be put on YouTube, and we have our own channels that you can see also an older webinar from my colleague in OpsWorks that is talking more about the Linux side of OpsWorks. Here's another question about resources in OpsWorks. If you can add an existing resource to an OpsWorks stack, for example, I want to add an existing RDS instance to a new OpsWorks stack. So yes, the RDS instance will be configured and installed outside of OpsWorks because we don't want to have the same UI twice in AWS. So you create your instance, and then you can use it with OpsWorks and just import an existing instance already. So I have a couple of questions about when you can get the PowerPoint slides and the recorded video. So at the end you will get an email, and they will send you the deck.